All right, we're back. We're on page 8 of Calc AB Notes 1, and we're going to do some derivative review problems or practice problems or whatever you want to call them. We're going to do them. So let's see. And find the first derivative of each of the following. So this is a product, so product rule. So it's first derivative of the second is 1 plus second. Derivative of the first is 12x by the power rule. And then we should probably clean that up. So what can we take out? Nothing. So that's good. So you get 6x squared plus 5 plus 12x squared minus 48x. So f prime of x is 18x squared minus 48x plus 5. And it's not going to get better than that. So I'm going to leave that like that. Let's look at this. So G prime, I see a quotient, so I'm going to use quotient rule. So bottom, derivative of the top minus top, derivative of the bottom, all over the bottom squared. Okay, so what does that give us? Well, this one's going to clean up. So you have x and then a minus x. You have a 5 and then a minus 3. So that's 2 over x plus 5 squared. So it's actually something you can do on this one that I like to do. So you can rewrite g of x. What I'm going to do is I'm going to do plus 2 minus 2 for reasons. So I'm going to do x plus 3, and then I'm going to do plus 2 minus 2 all over x plus 5, right? And so when you do that, plus 2 minus 2 just simplifies to 0. So it's still the same thing, it just kind of looks a little different. But if we combine these things, the plus 3 plus 2, we get x plus 5 minus 2 over x plus 5, which simplifies to 1 because this would be 1. And then minus 2 over x plus 5, because kind of like the remainder stuff, the remaining stuff, I guess I should say, this part would give me the minus 2. And then if I find the derivative of that, it's actually like a little bit easier to find the derivative of that because the derivative of 1 is 0, and then you're like using the quotient rule, but one of the derivatives is 0. So sometimes you'll see people do that. You'll see me do that mostly, but it's, it's an option. Let's take a look at this. So I'm going to call it dy dx just because we should vary our notation. Radicals are the worst. So let's first rewrite this. X to the 5/3 plus 5x to the 3/2. Okay, so 5/3, x to the 5/3 minus 3/3 is 2/3 plus constant multiple rule. So it's going to be 5 times 3/2, so 15/2. X to the 1/2. I'm going to leave that like that. You could try to factor. I don't think it's worth it. Just leave it like that. All right, what do we know how to do here? So we are, I'm gonna make it weird. I'm gonna make it 3x minus 2 squared times 3x minus 2, right? So I'm gonna, when I do this, it's like first derivative of the second and second derivative of the first. I need to know the derivative of 3x minus 2 squared, but that should just be the derivative of 3x minus 2 times 3x minus 2, which would be first derivative of the second is 3 plus second derivative of the first is 3. But if you look at it, you just get 2 of that thing. So you get 2 times 3, you end up with 6, 3x minus 2. Okay, so that's like a little bit of side work there because we're going to need that when we do this. So I'm going to say dy dx first, 3x minus 2 squared times derivative of the second, which is just 3, plus second, so 3x minus 2, times derivative of the first, which we already found down here, is 6 times 3x minus 2. Okay, so what can we take out? You can take out 3x minus 2 squared and you're left with 3 plus 6. So 3 plus 6. So our final answer here is 9, 3x minus 2 squared. And if you've kind of like read ahead or watched some videos ahead, you know there's an easier way to do this. We're going to get there, but until you know that way, this is it. This is how you're going to get to the answer. Or that's an efficient way of getting to the answer, I guess I should say. All right, let's see. I think I'll do the next two, and then I'll cut this and come back in the next video and do the next bunch. That's my plan. All right. So I'm going to call this y prime to vary it up. So first derivative of the second plus second derivative of sine is cosine. So cosine. So y prime is, I mean, you can take out x squared. I don't know how useful that is. Get 3 sine of x and then plus x times cosine of x, which is why I don't really feel like it's really windy out. I actually have a light on today because it's just so dark that I didn't think you'd be able to see me if I didn't do that. All right, so I'm going to do this one. I'm going to then check them on the calculator. I hope that works. And actually, let me fire up the calculator while that's happening. So I'll check them on the calculator. Sometimes that messes up the video. First, derivative of the second. So what is the derivative of natural log of x? It's 1 over x. Technically, x is greater than 0. You don't usually write it like in the middle of a problem, so I'm not going to, but it's there, plus second, which is the natural log of x, times the derivative of the first, which is 3x squared. So this will be, so I have x cubed divided by x is x squared plus 3x squared natural log of x. So this actually cleans up kind of a lot. So one of the things you want to do is when you have derivatives, you want to actually be finding the zeros of them. So trying to factor your answer makes a lot of sense. Let's say 1 plus 3 natural log of x. All right, so these are my answers so far. And what I'm going to do is as I get them right, because we probably got them right, I'm going to highlight them. I'm just going to go switch over to the calculator, see how this works. So I need to add a calculator page, and I want the, so I should use the template. So the derivative with respect to x of quantity 6x squared plus 5. So this one, another alternative would have been to expand this and just straight up power rule it instead of using the product rule. So we got 18x squared minus 48. Yes, so that's right. So when we go back to the notes, you will see that that is highlighted. And then I'm going to copy and paste because I find that like a little faster. I don't really know if it is. X plus 3, x plus 5. So 2 over, yep. Good job, us. Now the one that had a radical, which is terrible. I guess I'll use like the, there's an nth root template here. So 3x to the 5th, and then plus 5x to the 3 halves. So this gives me 5/3 x to the 2/3 plus 15 halves x to the 1/2 is how we wrote it, because mixing and matching your radicals and your rationals, like, what are you doing? So here, 3x minus 2, and then we're going to cube it. So 9 times 3x minus 2 squared. It's good. So you should always be checking. I mean, partly like you don't want to get to any point in the course where you're like, how did you do that on the calculator again? Like, be doing it all the way through. That's how you get successful at this stuff. Sine of x times. You don't really need the multiplication symbol there, but like just put it. Not hurting anybody. So we factored this. So factor, and you get x squared, x cosine of x, and 3 sine. Yep, got it. It's always interesting when we as humans factor more than the calculator. And then finally, derivative of x cubed, ln of x. Ln is how I say that, or I say log, one of those, or natural log. A lot of options. And we factored this too, and it didn't factor the answer. It's really concerned though, and it should be, and so should we, that the domain of the result might be bigger than the domain of the input. And in this case, it is. No, it isn't, because there's still a natural log, actually. If the natural log totally disappeared, the domain could have changed potentially. It's not allowed to change, right? We have to know that as humans, but it might have looked like it changed. And that's what it's warning us about. Like, hey, I might have done something you're not allowed to do. It knows it did it, but it still does it. All right, so we got each of these right. So that's great. I'm gonna come back in the next video and finish this page. So I will see you there.